We're now on day 2 of section 7.3. We're still dealing with page 444, or at least the section that starts on page 444. Now what we're going to do, yesterday we talked about graphing sine and cosine using transformations. Transformations A, B, and D. A being the amplitude, B being the period adjustment, D being the vertical shift, and also we talked about what happens if there's a negative in the front attached to A, or if A is a negative number is really what we mean. And remember that as an x-axis reflection. Now what we're going to do is we're going to talk about C. And C is referred to as the phase shift. Phase shift is just another name for horizontal shift. So remember we're talking about, in the case of sine, y equals A times sine of B. Sorry, my tablet is being a little bit cranky right now. B times x minus c plus d. Now, in the book, they write it as bx minus c in parentheses, like this. And I don't believe they even show the d, but that's okay. Here's the thing, guys. You do not want to try and graph these with b, whatever number is attached to x, inside the parentheses. What you need to do is you need to, if it's written like this, you need to factor the b out, which means we're going to divide each of these by b so that we can put the b on the front. That's very important, because if the b is inside the parentheses, then your C, your phase shift, is not going to be accurate. You need to make that adjustment to it still, and you'll probably forget to do it. So let me show you the way I want you to attack these. So the phase shift is, again, the horizontal shift. So we're talking about things like y equals sine of x minus pi over 4. Now notice there's no number attached to the x, which means this really is our proper phase shift. Our phase shift is going to be a horizontal shift of pi over 4. The question is, which way does it go, left or right? Remember back to y equals x squared, which was your basic parabola. Remember that when we did y equals x minus 2 squared, what that did was this actually moved us the opposite direction of what it appeared to be. Negative 2 seems like it should go to the left, but it actually goes to the right, because by subtracting 2 before we square something, in order to get the same value I used to get for y, I now need to plug bigger x's in to get that same answer. Bigger x's are to the right, not to the left. So that's why it shifts it to the right. Same thing here. The horizontal or phase shift is going to be the opposite of what it appears to be. So instead of left pi over 4, this is going to be a shift of right pi over 4. And so when we go to graph this, we're going to graph it the same way we did yesterday. My amplitude is 1, so 1 and negative 1. My period is 2 pi. This does not change the period. Only b changes the period. Pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Our parent function with the proper period and amplitude, beginning, middle, end, maximum, minimum. Here is our parent function with those proper values. Now I need to perform this transformation. So I'm going to switch to red. Notice, guys, that pi over 4 is what size relative to our first mark? Well, notice pi over 4 is half of pi over 2. So here's pi over 4. So what you do is you show me where that phase shift is, what that distance is. This distance, half of one of our big units, is pi over 4. So what we're going to do is we're going to shift each of our points half of a unit to the right. So this moves to here. This moves half a unit to the right, half a unit to the right, half a unit to the right, and half a unit to the right. And now that I've shown what distance I am translating it, now I can draw my curve with my phase shift. And red is my final. Sorry, bear with me a moment. My tablet restarted itself. There you go. There is our final graph. So that's a shift of, to the right, pi over 4. Now what you have to be careful of is when they give you things that look like this. They will give you things like y equals 2 cosine, notice this is the cosine curve, 3x minus pi over 2. Notice that b is inside the parentheses with the x. We don't want that, because if you leave it there, you're going to think that your phase shift is pi over 2. But your phase shift is not pi over 2. It's actually pi over 6. And the way that you see that is you factor the 3 out. So you need to change this into y equals 2 times cosine of 3 parentheses. Remember, when you factor something out, putting it back is multiplying, so factoring it out is dividing. So when you divide this by 3, you get x like we want it. When you divide this by 3, the 3 goes in the denominator and makes this pi over 6. So now if we identify our transformations, our amplitude is going to be equal to 2. Our period is going to be the old period for cosine, which is 2 pi, divided by that number, which is 3. And then this is going to shift us, because of the negative, again to the right, pi over 6. So notice that our phase shift, our horizontal shift, is pi over 6, not pi over 2. It's very important to factor that out. Okay, to draw the graph, we're going to start with the parent function with the proper amplitude and period, just like we always have. So these go first. And this is going to be second. 2 pi over 3. Half of that is 1 pi over 3. Half of that is pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6, which is really pi over 2, and 4 pi over 6, which is 2 pi over 3. We're going between 2 and negative 2. Cosine begins and ends at the maximum. Halfway it's at the minimum. In between it's on the axis. Here is my parent function with the proper amplitude and period. There we go. So we took care of both of those. Now we just have to take care of this one. So I'm going to do this one in red. Pi over 6, notice, is 1 full unit. So this is going to shift 1 full mark to the right, 1 to the right, 1 to the right, 1 to the right, and 1 to the right. If you want to label this, remember it's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. And now here is our cosine curve. And there we go. Red is our final. Don't forget to indicate that. So that's how our phase shift works. Pay attention to whether or not you need to factor it out before you actually start to graph these, or you're asking for trouble. Okay, let's do one more example, and then I'll turn you loose. Let's take a look at everything but the kitchen sink. Y equals negative 3 sine parentheses pi over 2 x minus pi over 4 plus 1. This is everything but the kitchen sink. Now, notice that we have an x-axis reflection. That's the negative. Notice that our amplitude is now 3. Notice that pi over 2 is inside the parentheses. That is no good. So we need to stop what we're doing and we need to rewrite this thing. Negative 3 sine, we need to factor the pi over 2 out. So pi over 2, then parentheses. And out of the parentheses, when I divide this by pi over 2, to factor it out, those cancel out and I just get my x, minus pi over 4 divided by pi over 2 is really pi over 4 times 2 over pi. Notice this ends up giving you 1/2. So our phase shift ends up being 1/2 here, plus 1 at the end. So let's do this again. X-axis reflection. Amplitude equals 3. This tells us that our new period is going to be 2 pi divided by pi over 2, which is really 2 pi times 2 over pi, which is really 4. Notice no pi in there. Our phase shift is going to go to the right 1/2. Obviously, this could go to the left as well. All my examples just went to the right, but it would work the same going to the left. And then we're going to go up 1. So we're going to do the period first and the amplitude first. Okay. What we're going to do then is I would then take care of the phase shift. So I would do this second. I would then do the x-axis reflection third. Now, could you flip-flop those two and do the reflection second and the phase shift third? Yeah, that won't cause a problem. What matters is this has to be last. Because if you guys do the vertical shift before you do that x-axis reflection, you're going to get the wrong answer. It's very important. You've got to be careful on that. Okay, so let's draw our picture. Let me get rid of this short one. Okay. So our period is going to be 4. So I'm going to go out here to 4. Half of 4 is 2. Half of 2 is 1. So 1, 2, 3, 4. I'm going up 3 and down to -3. So that takes care of this and this. This is sine. So beginning, middle, end, maximum, minimum. Draw the graph in. Again, don't forget to only work with the guide points. Next thing I'm going to do is shift to the right 1/2. So notice, guys, 1/2 is half of a unit, right? Because my units are going by 1s. So I'm going to shift this to the right 1/2 a unit, shift 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 to the right. This would be 5, 1/2 a unit. So now, oops, sorry, I meant to change to green. We'll put the green ones here. That's terrible. Let's make that a little bit better. You guys will run into that too. Just erase it, make it look the way it's supposed to look. Doesn't need to be perfect, it just needs to be accurate, relatively accurate. So there's our green one, that's our to the right 1/2. Now we have an x-axis reflection. I'm going to go to blue. So this stays in the same place. This point, instead of being at 3, is going to be at -3. This stays in the same place. This, instead of that -3, is going to be up at +3, and this stays in the same place. And so now I'm connecting the blue dots. And there we go. There's number 3. The last one is up 1. So now I need to put these units in. That's 2. That's 1. That's -2. That's -1. This is going to go up to 4. So I take this and I move it up to 1. I take this point and I move it up to -2. I take this point and I move it up to 1. This point and I move it up to 4. This point and I move it up to 1. And now I connect these red dots. And there we go. I don't like that last piece, so let's erase it. That's better. And red is the final. There you go. Now, what if they asked you to find X intercepts? Well, notice, guys, that this used to originally hit at 0, but we moved everything to the right 1/2. So 0 plus 1/2 is 1/2. So one of our X intercepts is at 1/2. This used to, the black one used to hit at 2, but it got shifted to the right 1/2. Right? The only problem is that this thing then got moved up. So the blue one, the x-intercept, is going to be 2.5. But now when we move this up, that becomes a little bit more problematic. So when there's a vertical shift involved, it's going to be a little bit tougher. But if there's no vertical shift, you're going to be able to just adjust your x-intercepts accordingly based on whatever left or right horizontal phase shift movement you had. Okay? Now, as far as finding them when you do have that vertical shift, like on this red one, you would not be able to find it easily. We know that this is 1/2, but we don't know what this is. We know this is 2.5, but we don't really know what this is. We know it's between 2 and 2.5. To find those, really you need to solve trig equations, and that's what we do in Chapter 8. So don't worry about that right now. Okay? All right. So that's the deal with all of our transformations now: x-axis reflections, amplitude, period adjustment, phase shift, vertical shift. Okay, I will see you guys tomorrow. Don't forget to take notes. Don't forget to write down at least one question. And try the easy problems so that you guys can spend your time in class doing the ones that you actually need my assistance with, so I can help you through the material.